Hey, John here. So we left off last time powering it up, and we saw the flash boot okay, but it couldn't read the SD card. All right, that threw me for a little bit of a panic. The last thing I need is a small change to have such an abrupt and significant impact, okay? Now, I couldn't get this thing to work, and I poked around a little bit, couldn't figure it out. So what I did is I decided to do something irrelevant, and I added these resistors here, thinking that, obviously it's related to the data signals coming off of this card, and thought maybe these effectively create a pull-down resistor, approximately 7,000 ohms, and maybe that had some impact on this card, no, it does not. I'm very sure it does not, but they're already soldered in, and I'm not going to take them all out to run this test. If anybody runs a card like this that does not have this SD card in here, does not have these resistors, because I'm sure they don't need to be there for this test, and the SD card adapter from SparkFun, let me know, as I'm pretty sure it should have worked when I did my first test. And the reason is because it didn't work when I added these resistors anyway. And again, no real surprise there, okay? What did work was for me to take the SD card out of this adapter, put it in this alcohol-soaked rag, and rub it and clean off gunk that might have been on here. Just, clean up the contacts. I put it back in here after cleaning it off. It went much more smoothly last time, right? That's my story. Power it up and give it the old boot. And it works. Woohoo! So, in conclusion, you do not need these resistors here if you're going to use the SD adapter card, and you do not need this SD socket here, and you do not need the surface mount parts on the back of the board here, the 3.3 volt regulator and its bypass caps. All right, so the board will work in that state, and that was the test that I wanted to do. Got me thrown off because the card was dirty. All right, so basically I'm sure this will be fine. In order to do the other test, I'm going to go ahead and put in the rest of the bypass caps now, and the regulator and stuff, and use the SD card on board to verify that that works. I'll also add the power LEDs and stuff like that. You put the LEDs in, remember they're polarized, so the long lead goes in the round hole and the short lead goes in the square hole, right? So they go in exactly as I'm holding this one right here, okay? The long lead goes away from the USB connector. Now, if you get too much solder on something that has a long lead like this, what I do is you melt the solder up, and then I run the soldering iron up the lead. And what it'll do is it'll take some of the extra solder and it'll distribute it up here on the lead, okay? And when you go in there with your cutters, you cut off the remaining lead, and the extra solder goes away with it. It's like built-in solder wick. Now, when I put on the voltage regulator, the surface mount ones, on the back, what I do is I put the regulator on first, and then I put the other capacitors on around here. And the reason I do it this way is because this thing needs more heat, and sometimes I'm poking around with the iron a little bit on here. If you put the little parts on first, they get in my way of the of attaching this big one. Sometimes I do it the other way around, but in this particular physical arrangement here, the placement of these parts, I find it easier to put the regulator on first. And when I do a part like that, I do the big tab here first. It's more convenient for me for whatever reason. Now there's enough flux inside the solder here. I'm using 6040 rosin core here. And this is pretty sloppy. I mean, I should have held it better. But I mean, this you got a lot of room for error here. And once you get one of the pins down on this thing, the rest are fine. And as long as you only got solder on one of the pins, you can move it around easy, remelt it and move it around. So that's on there, perfectly fine. We do the other 3 pins. And it's okay if you get solder on these other pads as you go, because you're going to need solder over there in a minute anyway. It'd be nice, though, if you don't. It's always easier to start with something that's clean than with something that is a mess. So if you don't create a mess, you don't have to work with a mess. There we go. I'll probably have to clean that up. Looks like there's too much solder on there. Okay. That looks pretty good to me. The middle one might be a little thin on the solder. But I think that's really only true because the other ones have too much. It just looks like that. Because these end ones have a lot of solder on there. So I'm going to try and get some of it off by just getting it to flow onto the iron and then wipe the iron off. Just take a little bit off at a time. So there's some solder right there on that pad. That's okay. If you're doing these little surface mount rectangular parts with the 2 pins, it's okay to have solder on one of the pads. Just don't put it on 2 of the pads before you put the part down. You can do it with 2 pads as long as you have one of those irons that has like the tweezers, so you can heat both ends at once, or hot air. Otherwise, it becomes very problematic. So C24 up here is a 0.1 microfarad. This one that runs across this way, C18, is 10 microfarads, and what is this one over here? C14 or C17? There's a blob of flux on there I can't read. Yeah, that's C17. This is also a 0.1. Somebody observed that some of these footprints don't match the parts. That's fine. Like these are like an 0805, and I'm putting an 0603 on there. I probably should have made all of them 0805s and make it easier for everybody. But it's no big deal to put an 0603 down on an 0805. Doing it the other way around, a big part on a little footprint, is much more difficult to deal with. Okay? All right, so here's some 10 microfarad capacitors I got lying around. These aren't the exact ones that I spec'd on the project, but they are 10. These are a higher voltage rating, so they're a little bit physically bigger. This isn't going to make much difference at all. It won't make any difference at all. So I'm going to go ahead and use these because they're handy. And this is why sometimes I've been a 0805 footprint. It's handy, even when you're going to use an 0603 part, because you might not have one in your shop lying around. I obviously have 100 of these, so I'm going to go ahead and use one. These sizes are nominal anyway. It'll probably run without any filter caps on here. But if you do things like that, like when I was testing it without the bypass caps just to save money if it failed, right? Then your problem is that you have more noise in the power supply, and then you end up having to question things like when that SD card didn't work because the pins were dirty. That's a little embarrassing. But one of the thoughts were, I wonder if the power supply is noisy. I mean, that would definitely cause something like that to happen. So, running around and starting to add bypass caps that should have been in there anyway, just because I'm too cheap, is the sort of thing you would end up doing. Questions that you start asking yourself, right? So try to do what the spec sheet says, unless you absolutely know better. And there's a clue there. More often than not, you don't. So don't make stuff up. Now, I don't think there's enough flux on here. I'm not sure it's going to get on the pad on the board right. I didn't put any additional. No, it's not getting on the board. So I'm going to go ahead and throw a little chip quick on there. It's one of these things, right? Now, as a hint, I do this all the time. So I have this old jar of, whatever, cheese or something from crackers from like a gazillion years ago. You can see in there's a little bit of alcohol, all right? Not much, just a small puddle in there. And what I do, whenever I'm done with using the flux, I take the tip off this syringe here and I just throw them in this jar and I just leave them in here forever. These have been in here for years. And the reason you want to do this, and I can't get them out without like a tweezers to reach in there. The reason you want to do this is because the flux will harden in here and then you'll never be able to use the tip again. Now, once you take it out of here, this tip still has a little bit of flux in there, but it's really runny and wet, okay? So do not put this in here and then tighten it down over anything important to yourself, because it's all going to squirt out when you do that. So I'm going to gently put it in here. I'm going to take it away from the jar and over a garbage can. I'm going to put this on here and I'm going to give it a little bit of pressure and squirt out the alcohol juices and stuff like that. All right, so you don't end up with all over your board. And now we're ready to go. So almost none of this is what you really want on there, just like the idea of flux. If you have too little, it won't work. If you have too much, you have to clean up the mess. That's the only rule. You cannot put too much on there when you're... Well, I mean, I suppose you could. The whole tube or something would be really a mess. But flux is a messy thing that you have to clean up later on, and it generates all this smoke, and the smoke, I'm sure, is toxic. So don't inhale that. Normally I operate with a fan running. Now this thing doesn't look like it wants to go on there. It might actually be on there. Let me get the eye loop. Give me a close look, and I'll be right back. Yeah, on really close inspection, it looks like it's on there okay. But the real problem is that when I stuck the first pin down on that pad, I left the part way over this way. It wasn't centered, and I should have moved it. I should have erred on the side of going that way, because this part now covers up that whole footprint, and it's really tough to see. Now, if you do this, and when you're getting going, this is the mistakes you can make. You can put the iron across the top of the component and heat up both sides like this. And once you've done that, you can also kind of do it on the side like that. Maybe that's easier to see on the camera. You can then take your tweezers. And of course, if you hit it with hot air, this is real easy to do. And you can kind of move it around a little bit if you're not sure if the thing is really soldered on there. And like I said, with a 30x loop, I could definitely see that it was soldered on there. Now, of course, it's completely messed up. So what I'm going to do is I'm going to just take the whole thing off. Kind of start over. You know what? I have hot air. I'm going to use it. Don't make me get hot air on you. You know what I'm going to do? I'm going to take the hot air and reflow the whole thing when I got all three of the resistors, or capacitors, I should say, on there, okay? Let me get some more of this solder here. It's kind of hard for me to do this while talking. I'm the number of mistakes I make with an audience is much greater than that without. That's my story, and I'm sticking to it. All right. You have a pair of 0.1s off your favorite spool. As you can see on the other pack, I usually buy these by the 100, or in this case by the 1,000. You're going to use a lot of 0.1s if you do these kind of projects. So I usually buy these by the 1,000, or sometimes I'll buy an entire reel. And those things last me a couple of years. I don't make that much stuff. But, you go through them, and the last thing you need to do is wait 3 days and pay $12 shipping for parts that are worth less than a penny a piece because you need 3 of them. It's just so annoying. I don't know about you, but I find that very annoying. And because I've been doing this for several years, this is my hobby. When I have to buy them, I just buy enough so that I'm good for a while. It's like shopping at Costco. How much toilet paper do you really need? And how much should you buy? 30 rolls is a perfectly reasonable amount to buy if you want a year's supply. Well, you don't have to go back again soon. This is feeling a little dry. I'm going to put a little more flux on these. When you're dealing with parts that are so small like this, that they use so small amount of solder, quite often the amount of flux in the solder itself, there may not be enough. So I'm like I said, this is not even a whole drop. That's just like the essence of solder flux on there, okay? Again, the toxic smoke. I usually run a fan, but it's so loud that I shut it off when I'm filming. So here's proof. Here's my fan, right, with a little charcoal filter thingy on there. That's usually sitting right up on here when I work. Now, these parts can be all crooked and messy if you have hot air, because what happens is when you heat them up, they're all going to just realign themselves. So if you got solder, if they're basically physically in the right place, and you have solder on the footprints, and then you hit them with hot air, everything will move to where it belongs. All the solder will reflow, hence the use of that word, and it'll look like it's super duper uber duper professional. Now I got to be careful. If I'm going to heat this up and I get it too hot, I may unsolder the thing on the other side of the board. The beeping, by the way, when I start with the air, it's letting me know that the temperature has reached its target. That's what that's all about. Let's try and keep the heat confined into this one area so things don't start falling off the other side. There we go. This is starting to move. This capacitor there started moving. This here is going to want to move a little bit. Okay, there we go. And probably more than enough. Doing any more is going to cause problems on the other side, so I'm going to call that done. And let the air gun cool down. Yeah, looks much nicer now. Everything's square, lined up, and the fillets look really good. See if I bring it in here under the loop. Looks super close. I'm looking really good there. It almost looks like it's professional. Turn it over to make sure that everything didn't fall off the other side. That's always a good sign. And the beep tells me that the iron is now cooled down. Now be careful when you use your finger to check for heat. That's still pretty toasty. So I'm going to let that cool down for a minute or two. I want to clean off now all this extra flux that's running all over the board as well, so that that's not a mess. Now this flux here could also go through these holes, come out on the other side underneath the SD card connector. So now that we know the board works, what I would recommend you're going to do if you're going to do this, and consider putting this on so you can clean all the flux mess off if any of it runs through the board into the area underneath the SD card before you put the SD connector on, okay? So I did this one in this order because I didn't know if it would work, okay? If I did, I was sure it would, but, you never really know. Now that I know that this design is rock solid and will work, and it's been tested and everything, I'll be able to do this in the correct order in the future and save myself a little bit of headache. When there's only just a little bit of flux to remove, I usually use a Kimi wipe and some alcohol. There's a little bit of a mess around these capacitors there. Looks like I was poking around too much on them. Some flux in there as well. If there's a lot of flux, you might need to go at it with, you know, a swab or something. But the problem with cotton swabs is it leaves cotton everywhere. The reason you use a Kim wipe is that it doesn't shred like paper. If you use a paper napkin, you get all this little fuzz in there. These Kim wipes are designed to shred in a way where it doesn't leave everything in your work. By Kim wipes, I mean these things. This Kim Tech Science brand delicate task wipers. Ooh. Lint guard, and this is the the whole thing, right? It doesn't turn into a big old mess of junk. I don't know, whatever. That's what I'm using if you want to know. And you can see it does leave a little bit, but it leaves it in giant shards so that you can get it out of there and not having all this fuzzy, hairy stuff everywhere. Oop, there's another fuzz over there. Okay, so it's real easy to clean it up if it leaves anything at all. And it only did that because I got rough. I was impatient. Okay, so now we can boot off this SD card slot here, probably. And we can see how well that works. Fingers crossed. Woohoo! It works! Test the reset button. And test adventure. It ran, it stopped, and we know from before that does a warm reboot and everything. So this is working perfectly normal, as from all intents and purposes. Now, these jumpers here are moved over to the right, as shown, obviously. And when they're in this position, what happens is this oscillator here is jumpered directly into the SIO. So I'm not running the CTC right now. If I move them over to the other position, then I'll be going the clock through the CTC, and by default, the BIOS and the flash boot code configures the clock to run at the correct speed for 9600 baud. So by changing this over, it will verify that this is working. We already know the SIO works. We know the flash works. We know the static RAM works. We know the obviously, because the thing boots, right? So all the select logic that turns this on, copies into the RAM, turn it back off, all that game that we went through many times in the past, all that's working fine. And of course it should, because the only changes in the PC board are the power distribution over here, the clock terminations, and the printer port config, which I'm not even running right now. But the exciting news here is that I didn't break anything. That is the important part. Let's pull off the power. Let's move these jumpers over to the left. Oops. Get the things out of here. There we go. Power it back up, and we should be in 9600 baud. Terminal in the right speed. Yeah, we need to be 9600 baud now, right? There we go. And power it back up. Looking good. Woohoo! Thumbs up. So now I got to add the printer header and plug in the printer and run that test, and then I think we'll be 100%. So that gives us our complete build now with all the headers and everything of our revision for RC1 release of the Z80 Retro board. I guess I'm exaggerating a little bit. I don't have the user jumper in here. I don't have the flash select jumper. I don't have R16, and I don't have this one over here, R15. These 220 ohm resistors are optional. They're not present in the revision 3 design. They terminate the oscillator clock outputs, okay? I'll do another video. We'll analyze those signals and I'll explain why they're there so that we can see it on the oscilloscope. But for now, this is compatible with the Rev 3 board. It has the correct connection from the printer port back into the SIO that we can use that works correctly without glitching when the printer works. Now let's move on to the new version of the Flash programmer. This is revision 2. All along I've been using revision 1. Again, I want to make sure that we verify that revision 2 works as advertised, and I want to see it with my own eyes before I tell everybody it's fine. I'm sure it is, because this board here has been modified. If you look closely, I made solder bridges on the reset lines. I've talked at great length about how and why that all works. And I've added these diodes over here that protect voltage from spilling into these chips here and potentially destroying the input transistors if there is a situation where the Pi is powered on while the Z80 Retro board is powered off and this jumper's not present, which I don't recommend you running it that way anyhow. But it was an option I wanted to be able to have, you know, it's one of those, might be nice if it ever is needed down the road. But with that in play, I needed to add these diodes here to protect these chips if the Pi is on and the Retro's off, okay? So let's go ahead and tear into this and see what's going on here. All right, so what else is different? I'm just reminded, you see this hole here? That one there is moved up a little bit like that on the newer board. The reason that's that way is over the months I've revised this board and I added that jumper header right in there. That's user 1. Okay, it's just one unused binary input pin on one of these buffers allows us to read that header if we want to. I tested it on the Rev 3 board. It works great. But if you install a header there and you use this Rev 1 board, that hole lands right on that header. Well, before the header was there, this was a good idea. Not such a good idea with a header in there. So I moved the hole up so that it lands just north of where that header should be if I install it. Now, hopefully this is in the right spot. I can't really tell by just kind of eyeballing it here. But when I'm done, I'll mount a standoff like this on there and see if the thing sits down there correctly. I certainly hope it does. That was the intention. It works okay without it, but as it is, if you put it on like this and you're pushing the Pi cable on there, it'll want to bend a little bit. You know, it was intended to sit nice there, and it doesn't want to fit. All right, so I fixed it. So this is very straightforward. I've explained the differences in some detail in earlier videos on my channel. I'm just going to go ahead and assemble this up and fire it up and try it out. Now, my original design for this included 10 microfarad capacitors at C5 and C7. That is literally 10 tons of overkill to make sure that the voltage is stable and clean in this circuit. And if we're pulling it off the Pi or a USB adapter, it's probably fine. They're certainly not going to cause a problem. I suspect the reason I did that was because of all the trouble I had with these chips crashing at random periods, which turned out to be a screwy situation in the schematic that I talked about in an earlier recording. And again, it's sort of like not going back and updating the resistor values to reduce the number of unique sizes on the BOM. I left these in here. So, I mean, does it matter? No, not really. I don't think we need them. I'm going to go ahead and put this header in here because I want to shunt that. I've never used J1. J1 is useful if you want to bring in, your I2C from another device, as opposed to just shoving a ribbon cable onto a Pi over here. So I want a 2-pin header, and I want these headers in here, and we're good to go. Now let's do a quick eyeball and see if I got that hole in the right spot. 9 months after I started this project. Will it align? Actually, I can't really see so well. Let's just move this standoff over there. See what happens. Oh, this is just a 3D printed, prism. And this screw here, the bolt, actually threads right into this. This is PETG, which is a very rigid material. And if you 3D print the hole just the right size, you can use it as kind of a self-tapping screw. And I find this to be really nice for things like this, at times like this. Oops, that end is a little bit crooked. This end is flatter, okay? And even if you take the bolt out and put it back in repeatedly, it's going to do a fairly good job. Again, with PETG, this is true. If I was to print this with polystyrene, hips, then every time you put the screw in there, it would just chew up. That's really brittle stuff, the hips is. PETG is way more rubbery, so it's going to survive a lot of insertions and reinsertions. So when I put this on with that in there, it's sitting in there right. It's really difficult to see. Oh, wow. If anything, it's too far up that way, because right now I just got it hung up on the, here, I'll show you. Oh, that's not true. It's hung up on the edge of this case because I open it like this and the angle sticks in, and this got hung up on the side of the socket for this chip here. So I guess the key is to don't put it, don't treat it like a hinge like that. Set it in there and then put this thing in. If we look at it, yeah, I can feel it just did it again. Oh yeah, you can see it in here. So if anything, I could move it that way a little bit, but this is really more of a matter of, put it in down, straight down, and it will be fine. Oh, that's beautiful. That is. Now I got to go find the other one for that other corner. I could put one over here and there too, but this is pointless because the connector itself fends for itself, unless of course you wanted it bolted on rigidly, which is really kind of pointless for this particular project, because once you get the flash programmed, the rest of your time you pretty much are going to spend playing around with CPM on the SD card anyway. But when you're early on debugging and your iteration rate of reprogramming your flash, this is nice to just leave it on here, which is what I did for many, many weeks early on in the project. So there you go. Let's fire it up. Now I also put some rubber feet on the retro board here. Now, these you can just buy a sheet of these things anywhere. These are actually starting to yellow. They were clear when I first got them, like 20 years ago. I just got like a big sheet of these from a place called allelectronics.com. They liquidate or whatever. You can get these things on Amazon, just about anywhere. Just look around. You should be able to get a whole bunch for like really cheap, like $1 for a whole page full of them when they're dumping them. Otherwise, you might have to pay a whopping $4 or $5 for a a several year supply. The reason I put the rubber feet on here, by the way, is you get a little bit of grit or some little teeny wire flecks. The last thing you want to do is have this board pick that up. Especially with, I didn't clean every little bit of flux off of this thing, and that flux is sticky. So if there's grit or, metal is the worst enemy, right? Any metal pieces of wire or something will, sitting here, it gets stuck on here and eventually build up and cause problems, short something out. You don't want that. So I put rubber feet on any board that I'm going to use sitting around on a mat like this for anything longer than while I'm building it. All right, I'm plugging this stuff in to get ready to get her going. I got the network plugged to my my workshop network. I got the USB power here. The supply is not online right now. And what else we got? We got this plugged into the Retro. You gotta make sure that you eyeball, make sure this is in right and not, off by a row of pins or something like that. And this board is designed to match the one underneath it. So if it's off, you should notice it, but take extra care. These chips are in right. You can see the giant slugs up here indicating pin 1, and the notches are both facing up. Everything's fine. I don't need this header because I'm not going to use it in these capacitors. As I said earlier, are overkill anyway. This ribbon cable here with the red line matches the giganto slug here, which indicates where pin 1 is on my board. So I get it plugged in right. Does this go this way? Does it go that way? How does it go? You look at the Raspberry Pi, and this is a beautiful example of, honestly, they could have done better. They don't have a in-your-face pin 1 is here indicator. If you look really closely, there is a little flattened notch on the footprint right on the corner there where it says like J8 or whatever the symbol is for this connector, which is hard for me to see with my eyes. You can also flip it upside down because we all know that the one with the square pad is on pin 1. I don't know how well that's going to show up here. Which is this one in this corner here. All the other ones are round when you look at the other corner. So you know where pin 1 is if you want to look. My point is, these slugs, you can see this a block away. This is supposed to be kid-friendly, all right? Come on, put a giant arrow, hit 1 or something. That would have been a good idea. Hence all the big and bright pin 1 slugs on the retro board. Why? Because, who hasn't plugged something in backwards at least once and then watched it fry? It sucks, and does it need to? Does it really need to suck this much? All right, it's all plugged in and on. I do not have an SD card. It's not on, but it's all plugged in, ready to be turned on. No SD card, because what I'm going to do is I'm going to boot up the Pi, I'm going to play around, and I'm going to reflash it with a new copy of the bootloader. I'll recompile it so the date changes so we can see that we got the new one versus the old one and know that the download worked. Okay, so since the Z80 is being powered off the Raspberry Pi, it makes sense that it booted up and there's no SD card, so this is exactly what we'd expect to see, all right? Well, I logged into the Raspberry Pi, and what are we going to do? We're going to replace the bootloader just to see if we can test the flash thing here, right? So cat readme, and there's my note to myself on how I'm supposed to do this. And when it's done, I think it's going to reboot the Z80 anyway. So let's go ahead and run this. Oops, I lost my console window. And see what happens. Not exactly going very fast. Yeah, maybe, boy, I wonder if my settings got updated. Yeah, this Pi, I might have to go back through and redo my settings. I'm sure the bitrate on the I2C is horrible. Because as you recall, the default was very low. I think I've done updates and things on this Pi since we last used it. Obviously, reading is faster, but still really slow compared to what the potential is. So, yes, okay, so what did it do? Well, before it was last updated in February. Now it was updated today, and it's about 1:49, yes, in the afternoon. So, woohoo! Looks good. I think that's a successful test of the flashboard. Okay. So, we'll do some more detailed tests. Recheck the printer and check the glitching and all that other stuff another time. This video is way into overtime as it is. So, yeah, so there's how you build the release for RC1 version of the board. And once I verify the printer stuff is optimal, let's make a real I'm going to release this thing on the GitHub for officially. So thanks for watching, and I hope that if you want to build one of these things, I mean, you can do it in a night, a long evening. Of course, it takes a little less time, right? If you keep the tabs on your SD card clean. Thanks for watching. I'll see you next time.